All right, so we're going to finish up this area. I probably should have put 12.3b, but that's okay. Because we did quite a bit of it on Friday, I guess it was. But we're going to finish it up today real quick. We got two basic formulas to go over. And I'll be honest, I have never seen these formulas before. Isn't that crazy? Taught geometry for years and years and years. And in any of the books that I've taught out of, I've never seen this formula. It's a pretty cool formula. Both of them are. I wish I would have known it. But it's but they put it in this book. I took some notes on it, and we're ready to go. So I'm going to write down the formulas, and we'll do a couple examples that show an example of each of those formulas, and then that'll be it. Then I'll let you work on the homework, or if you have questions on the first part of this, we can go over that as well, okay? But I just want to make sure I get the lesson done today, so I'm going to do that first before I answer questions on the homework. Okay. The first one, and you've recognized the first part of this, it's called the side angle side area theorem. Okay? And here it is. So what it is, you can take any triangle. It does not have to be a right triangle, which is nice about this, okay? If you have a right triangle, it's not that hard to find the area. It's just 1/2 the base times the height, right? Because on a right triangle, one of the legs is the base, the other leg is the height, no big deal. But what if you have a triangle that is not a right triangle? Well, this is one thing that you can use, depending on the information they give you, all right? It all depends on the information. So if they give you a side, and the angle that's in between the two sides, if they give you that information, you'll be able to use this theorem to find the area of that triangle, okay? It doesn't even have to be a right triangle. It could be acute, could be obtuse. So I think it could be obtuse. Haven't studied it quite enough. So area of a triangle is equal to, now, here we go. I'll draw a picture here in a second, but let's just write the thing out first, okay? So it's BC times the sine of A. Okay, that's one of them. You're actually going to get 3 different versions of it, all right? And then it would be AC. Now, you don't have to use all 3. You're basically just using one of these versions, okay? So it's AC times the sine of B, and you'll see a little pattern kind of developing here. Do you see that? Look, if you take the sine of A, what are the other 2 sides? BC, which are the sides that are not opposite what? A. Everybody see that? Okay, so if you have an angle in a triangle and you know the 2 sides that are adjacent to it or next to it, all right, then you can use this. Look at this. What if you used a different angle? What if you used angle B? Then you use the other 2 sides, okay, again, the one that's not opposite angle B. So what do you think the third version of this is going to be? Let's do the first part. What do you think you're going to take the sine of?
C.
Right, you're going to take the sine of C. So what do you think these are going to be right here? A and B, that's right. Do you see the pattern? All right, so basically it's this. Here's an angle that's between these 2 sides. This angle right here, angle B, is between side A and C. This angle right here, C, is between A and B. So let's draw a triangle. This isn't really the example, but let's scooch it up a little bit. Yeah, I'm trying to make it not look like a right triangle. That's pretty good right there, I guess. All right, so let's call it A, B, C. Those are your angles right there. So if we call this angle A, what am I going to call this side right here? Instead of calling it BC, I could call it just one letter. What could I call it? It's A. Why? It's little a. That's right. Yeah, it's little a because it's opposite angle A, right? So that's what they do right here. That's what they're referring to. Jimmy, do you need to sit up here? Okay, so what's this side right here, AC? Instead of calling it AC, what's an easier way we could call it? Little b. That's right. And this one would be little c. All right. So how do you do this? Look at it. Look at it. If I picked angle A as my angle, if they told me angle A and they told me side C and side B, then I could find the area of this triangle, right? Just by using this formula right here, the side angle side area formula or theorem. Because look, here's angle A. This side is B and C, right? So if they told you what angle A was, and they told you what side B was, and what side C was, you would be able to find the area of this triangle. With me? So, and same thing with the other ones. If you knew what angle C was, and you knew side A and B, you could find the area of the triangle. And one more, if you knew what angle B was, and they told you side A and C, then you could find the area of the triangle. Make sense? Yeah? Okay. So that's not too hard. We'll do an example in a few minutes, okay? But that's what the formula is. If you want to put it in a box, there you go. It's in a box. I always like to put important stuff in a box. So there it is. Now, really, it's not three different formulas, is it? If you just generally remember that you take the angle and the two sides that are next to it, right? If you know those three things on your triangle, you'll be able to find the area of that triangle. Make sense? Thus, the side angle side. You understand why it's side angle side? Because if I know this side and the angle between those two sides, then I should be able to find the area of it. Make sense? Yeah, it's not too hard, is it? Let's do another one. Everybody got that written down? So the next one we're going to do, they call the side area.
No, but there is that.
All right, so this one's called the side area theorem. So what do you think? So what do you think the situation is that you'll be able to find the area of a triangle if they give you what? If they give you all three sides, okay? If they give you all three sides of a triangle, they don't tell you any of the angles whatsoever, okay? They don't tell you any of the angles, right? But if they give you all three sides, you should be able to find the area of that triangle with this theorem right here. They also give it another name. It's named after some guy. I looked him up briefly. His name is Heron, Heron. Sometimes they call him, I don't know how to pronounce. I guess it's Hero, Hero, without the N on it. I don't know if they say hero or hero or whatever they say, but he died in like 90 AD. All right, so he was alive. I didn't even remember when he was born or anything, but he died in 90 AD. That's the only thing I remember. But he was a Greek mathematician. He did a lot of his work in Egypt. So this is a long time ago. I mean, this was just after, not very long after the death of Jesus, and he maybe, most likely, I don't remember when he was born, but most likely he probably lived in the same era that Jesus lived, okay, or close to it. He was probably a lot younger, but anyway, it's kind of interesting. So that's how far it goes back, right? And you probably don't even think that people back there did any math, right? They probably just walked around in sandals and some kind of tunic or something, whatever they call them, some kind of robe, and they just walked around. No, they did. They knew a lot of math back then. Okay, remember, Pythagoras was even before Jesus. All right, so they knew math. They knew a lot of stuff back then. So anyway, some people also call it Heron's formula. So he's known for this. I'm sure he did a whole bunch of other stuff. And I did read just briefly about him. And he did a whole bunch of other things. He did things with like engineering and physics and things like that. And again, you don't think about people way back then knowing about that kind of stuff. But they did. They had to build buildings. You can't just, prop stuff up. You got to know about like what loads they can handle, the angles of things to get the strongest structure, all kinds of stuff like that. That's engineering. And they knew about that stuff even way back then. Obviously, we've learned a lot since then, but they knew way more than what you probably thought. So let's quit talking about that. Let's show the area of a triangle. Area of a triangle. Now again, this is a situation where we only know the three sides. We don't know any angles. All right, we only know the three sides of the triangle. Then we can use this. I'm going to write it down, then I'm going to explain what one of these letters represent. Okay, you should know what three of the letters are. Just represents the three sides of the triangle, A, B, and C. But they throw another letter in here that we're going to talk about in just a second. All right, so it's a big old square root. Okay, so we start with a square root. then we start with the letter S. I'm going to talk about in a minute, after I write down the theorem, I'm going to talk about what that letter S represents. It's really not that difficult, but we'll see what it is. All right. Now, again, this kind of follows a little pattern. So it's going to be times S minus A. And then I'm going to go S minus, what do you think the next one is? B. And then what do you think the next one is? So it's S minus C. There you go. So it's really, it looks kind of complicated, but it's really not. It kind of follows a nice little pattern. You start off with the S. I'll talk about the S's in a second. Start off with the S, and then you just go the S minus the A, minus the B, minus the C. You multiply all that together, then you take the square root of it, and then that's what the area of that theorem is. They talk about the proof. Like I think there is a proof in this section on that first theorem, the side angle side area theorem. They do a little bit of a proof. It's really not that hard. But on this one, they say we're going to save the proof for later courses. So that must mean that the proof for this is kind of difficult. So we're not even going to worry about like why this is what it is. Okay? Yes, sir. That's what I'm going to tell you right now. Okay? So S is called the semi-perimeter. It's half of it, exactly right. Semi-perimeter. So you know how to find the perimeter, right? So what would the perimeter of this circle be? I'm not a circle. What's the perimeter of that triangle going to be? Well, all the sides added up, right? Because you don't know they're all the same, right? So all the sides added up. So the perimeter would be A plus B plus C, correct? They throw that word semi in there. What do you think that means? It means half. It means half of it, okay? Like a semicircle. You've heard that before, right? Okay, semicircle would be half. So it would be half of a circle. So a semi-perimeter would be half the perimeter. So what are we going to put out in front of it? How about a half? Okay? So that's what S is. All right? So if you know what S is, so I would find that first. If you know all three sides of your triangle, find the semi-perimeter first, and then from there, you can take that and then put it in for the S right here. So whatever you get for that, you'll get a number, all right? And you just put it in here, 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 here. And then what do you do with that S? You minus one side from it, you minus another side from it, and you minus the third side from it. Okay? Yeah, these are all being multiplied. There's no plus or minuses in between, right? They're all parentheses. There's nothing in between. So that means you're multiplying them all together. We got it?
Yeah.
It's really not that hard. And I can't believe that I've never taught this before. I've never actually seen it before. At least I don't remember ever seeing this before. I don't know. Maybe it's something we skipped over. But it doesn't seem like I've taught a lot of years of geometry, and we've hit a lot of topics, and I just never remember this one. But there it is, right there for you. It's really not that tough. Let's do an example, and we'll quit. Well, at least we'll quit the new stuff. So I'm going to draw a triangle. I'm going to try to draw it so it doesn't look like a right triangle. There we go. All right, so here's the situation. Let's pay attention, please. So this is 5. Does that mean this is 3 right here?
Yes.
Does it?
No, it's not a right triangle.
It's not a right triangle. It's not. Equilateral's got nothing to do with it. Equilateral's got nothing to do with it. This is not a 3. Shh. Guys, please. So this is not necessarily a 3 because we don't know that this is a right triangle. So you can't say that's 3. So you don't have a 3, 4, 5 triangle with any triangle. You can only have a 3, 4, 5 triangle when it's a right triangle. We don't know this is a right triangle. And this will tell you right now that it's not a right triangle. Okay? Well, actually, that doesn't really tell you. But we don't know it's a right triangle. And there's no way to tell that that's a right triangle from the information that's given. This is the information they give you. So they ask you to find the what?
The area.
The area. So they ask you, I'll put a question mark there, they ask you to find the area of it. So what situation do we have? We've learned two situations. What were those two situations?
Side angle, side.
Right, so which one is this? Is it side, 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 or side angle, side?
Side angle.
It's side angle, side. Okay, it's obvious, right? To me, it's obvious, isn't it to you? Right?
Okay.
And I just learned this just recently, okay? So this is just as new to me as it is to you. So this is one of the sides, and this is the angle that's in between. So do you remember? And it doesn't even matter like what we call A, B, or C or anything like that. What does the basic formula tell us to do? It says take the sine of the angle, right? So take the sine of the angle, and then we multiply two things together, and we multiply it by this. What are those two things that we multiply together? The two sides, right? The two sides that are adjacent to that angle. So what are they?
5 and 4.
Right. So 5 and 4, or 4 and 5, doesn't matter how you do it. So right there, there's your formula. That's it. Really simple. You just take the sine of the angle, right? And then you multiply it by the two adjacent sides. So the formula itself looked a little more complicated because there was three things to it, right? There was like BC sine of A, and then there was AC sine of B, and all that kind of stuff. But if you just look at it, you just take the angle in between, take the sine of it, and then the two sides that are next to it, adjacent to it, everybody see that? You just multiply that together. So you just stick that into your calculator, and you get approximately, I should put approximately, because the calculator answer will be approximate, and you get approximately 9.7. This was in meters, so this is going to be what? It's area, so it's meters what? Meters squared. So that right there is the area of this. Why'd they cut it in half? Did they?
Yeah, 1/2 of 5 times 4 is.
I don't know. Let me look at it. Don't know. Let's go back to the formula. There's no half in the formula, is there?
No.
So is that 9.7 when you take half of that?
Yeah. What's that? Yeah.
It says the area of a triangle is equal to half the product.
Oh yeah, that's it.
Yeah. That definitely makes more sense that it would be half. Yeah, because if you look at the theorem, if you look at the words, guys, I'm not done. Why do we do this? This is like the 15th time in like 20 minutes today that I've had to get you to settle down. Come on. Quit acting like little kids, all right? Act like you're a serious student. For goodness sakes, you're an honors geometry student and you're finished basically your 9th grade year. And you're still acting like a little 3rd grader. I got to tell you to be quiet every 2 seconds. Just do me a favor and act grown up for like 1 class period. It'd be really nice. So if you look at the words on page 591, it does say the area of the triangle is equal to half the product of the sides. But then they give you the formula, and it just says area equals BC times the sine of A. My guess is they just forgot to put the 1/2 in there when they showed you that little formula. So I'm glad that you brought that up. So let's revise that a little bit. So I'll have to do some double checking on this, but it does make sense. It would be 1/2. It absolutely makes sense now that I think about it. So it should be 1/2 in front of this, but they don't do that in the book, and I'm gonna have to I'm going to have to look in that a little deeper and find out why. So let's put the 1/2 there. And it really shouldn't make it much more difficult because what is the area of a triangle? It's 1/2 the what? The base times the height, okay? And what this is going to do, they kind of, I'm not even going to talk about that. But anyway, so yeah, so it's 1/2 because it is a triangle. Yeah. So throw that in your calculator, put a half in front of it like that, and then that should be the area of this triangle. Now we're not finding, it's not the third side, is it? Okay, we didn't find the third side. We're going to learn something, is it tomorrow? When do I do law of cosines? Tomorrow? Yeah, so tomorrow we're actually going to learn how to find that third side, even though it's not a right triangle, okay? So, but that we're finding the area, okay? We're finding the area of this thing right here, all right? Let's do one more example, and we're going to use that Heron's formula, or the side one. Probably easier for you to remember side, because it kind of describes what kind of triangle we're working with. So it looks like this. All right, so they tell you that this is 10, they tell you this is 7, and that this is 9. All right, so can we use that side angle side? No, we cannot, okay, because we don't know any of the angles. Because we don't know any of the angles, all right? So we need another way, and the other way is that side one that we learned. So do you remember what it is? The area equals the square root, and then it's S, and then it's what? S minus one of the sides, and then it's S minus one of the other sides, and then it's S minus the third side. And what is S? It's the semi-perimeter. So it's 1/2 the perimeter, which would be A plus B plus C. My little pen's getting a little shaky. I have a feeling the battery might be dying on it. Okay, so yeah, let's find the semi-perimeter first, and then we'll stick it all in here. So it's 1/2 A plus B plus C. So let's just write it down. 10 plus 9 plus 7. All right, what's that? That's 19. That's 26, right? And then half of 26 is 13. So that's 13. So that's the first thing that we do. We first find the S, the semi-perimeter. All right, so we find the perimeter, take half of it, and that's 13. Now we can plug it in to this whole thing right here. All right, so we got a 13. And then I'll write all the steps out. We have 13 minus what? Right. Doesn't matter which one you use as long as you just make sure you put each one in there. Then it's 13 minus, well, I'll tell you what, let's go in order from the biggest to the smallest. You don't have to. It doesn't make any difference that you do, but I'll just do it that way. And then 13 minus what? 7. Now, if you just want to put that in your calculator, you can, or you could go, 13 minus, you could just go 13 times what? 3 times, what's that, 4? And that's 6, right? Take the square root of all that. Now you can chuck that on your calculator. It's 936. Oops. Square root of 936. I would just chuck that in the calculator and get an approximation. I'll put it, yeah, so you get about 30.6. I didn't show you this, but they do put it in inches. So this will be what? Inches squared. Okay, and that's the area. Okay, see, so that's the area of this triangle. It's about 30.6 inches squared. And there you go. That's how you find the area of a triangle that's not necessarily a right triangle. Okay, yeah, that was pretty good. I learned a little bit myself, and I learned that potentially the book might have made a mistake. So that's always fun to find. Found that quite a bit. I think in my physics book, a long time ago, I taught physics in my other school, and you should see all the mistakes that we corrected in the back of the book. There was quite a few of them. But anyway, that just goes to show that everybody can make a mistake. All right, anything with that?
No.
What's the homework I gave for that? That's right. I didn't give you homework last night or over the weekend, did I?
No.
Yeah, it's because I'm so nice. All right, so we're doing 5 to 18.
5 to 18, we just give all the book back on.
And that's section 12.3. Now, if you've noticed on your lesson plan, did you notice any gaps?
Yeah,
Yeah,
we
no,
still-
we're not doing 12-4, 12-5.
Right. So we skipped from 12.3 all the way to 12.6. And the reason for that is obviously time. Okay, we don't have enough time. Now, we are not using the entire week next week to review for the final, right? Because we are going to take a test on this stuff. I think somebody asked me earlier whether we're going to include this on the final or not. I decided I want to have a straight test because we've had so few grades this marking period because it's gone so quick. We've had Easter break and all that kind of stuff. I need another grade in there, right? So we'll take a test. We're not going to take any more quizzes, it doesn't look like. So we'll just take another test, and that will be next week. And it'll be on Monday. We rarely take a test on Monday, but just because of time, we're going to take the test on Monday, okay? Good. Okay, that's it.